In question number 5, which is also a past paper from Cambridge, but not IGCSE, GCSE, paper 2, okay, May, June 2011, question number 4. It's not core paper, they don't have core or extended. Okay, what do we have here in this question, question number 5? The figure below shows a circular wavefront produced at the center of a circular ripple tank. Okay, so we have a ripple tank and we have a source here that we have ripples that spreads out in all directions, okay, with the same depth, since the waves are having the same separation distance, the wavelength, it's constant. Two corks, okay, the cork A and B. You know what's the cork? The cork that it come out from the olive oil bottle or the champagne bottle, okay? This one is cork, it floats above the water because it has low density. What do we have? Two corks A and B floats on the water, okay, in ripple tank here. They move up and down on the surface of the water as the waves pass. The wavelength of these waves are 8 centimeters. The distance between wave crest to another wave crest or wave front to another wave front, it's what, 8 centimeters. This is the wavelength, okay? The figure below shows how the displacement of A varies with the time. Cork A, with the time, how the displacement up and down, okay, 2 up and 2 down millimeter during what the time and this is repeated every what 0.5 what second. Okay, A, state, that means you already know the answer. State the amplitude of the vibration of A as the wave passes. How much is the vibration? Exactly 2. If we wrote it like this, we are not good getting the mark. We have to put it 2.0 exactly millimeters. Okay, we have to write the answer sometimes in 2 significant figures, 1, 2. The 0 is a significant figure. Part B, the horizontal distance between A and B here, the horizontal distance between A and B, as you can see, if A is on a crest and this line it's also another crest, that means B it's in the middle, exactly at what? At trough. So it's half wavelength. So look what they said here. The horizontal distance between A and B is half wavelength, okay, on the wave. On the same previous figure, this one, the graph. Sketch a graph to show how the displacement of B varies with the time. Now, as I told you, when A is on a crest, B it will be where? On a trough, because it's half wavelength, it's half distance. So if they give it us that this is a positive amplitude going up, that means B is going where? It is going down. And vice versa. If A is going down, that means B is going what? Is going up, like this. Now, what do we know here? We have information that sometimes they neglect it. You will not lose a mark if you don't draw it or you don't mention it. What is this information? That these types of waves, water waves, it loses energy during what? During distance. So, for example, if there is another cork, okay, this is the cork A and this B, there's another wave here, another wave here, another wave here, another wave here. Okay, if there is a cork at position C, which is very far from the source, and they ask to draw it, C, it will be similar to A because it's on the crest. The separation distance is number of wavelengths, okay? But since it is far, so the amplitude it will be a little bit smaller than A. That's it, because it's far. That's it. If they ask about point C, but in this question they didn't, so I will not put it in my answer, so you'll not get confused. But whenever the object is farther, that means the waves will be less amplitude, less energy due to the energy dissipated due to the distance. Okay, tamam. So if you want to draw B a little bit less than the amplitude of -2, I think it is accepted, but don't worry, they will not put marks on that. Okay, unless they give you information. Tamam? Okay, this is question, part B of this question. Part C, use the same previous figure to determine what? The frequency. How we can find the frequency? Bravo, Tina. We can find that the period, it's the time for one complete what? Wave, which is how much? 0.5 seconds. So we know that period and the frequency is the inverse to each other. Okay, so the frequency is 1 over period, which is 1 divided by 0.5, and 1 divided by the time, which is 0.5, it's 2. So the answer is 2, but I will not keep it like this. I'll write 2.0, and also what I will do, I'll write the unit, and which is what? Hertz. We have to write a complete answer to get what? The 1 or the 2 marks, okay? Tamam? Double I. The distance between the center of the ripple tank and the edge is 40 centimeters. Determine the time taken by the wavefront to travel from the center of the edge to the from the center of the tank to the edge. Now the distance between the center to the edge is what? 40 centimeters. So that means we know that speed equal what? Distance divided by time. They ask about the time. So that means time equal distance divided by what? Speed, okay, or velocity. Now we know that the distance is 40 centimeters. We can keep it in centimeter if the speed is in centimeters. So this is the second step. What do we need here in first step? First step, I need to find how much is the speed of the wave. And we know that the speed equal frequency multiplied by wavelength. And the frequency, we just find it out, which is 2, multiplied by the wavelength, and they give it to us in the graph and in the information, which is 8 centimeters. So that leads us that the speed is 16 centimeters per second. I'll substitute it here. So the distance, which is 40, divided by the speed, which is 16. So 40 divided by 16, it will be 2.5 what? Seconds. That's how long it does it need to make the water waves reach from the center to the edge of the ripple tank. Any question? Is it clear?